To everyone, this is Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about water treatment methods. By using water treatment methods, we can remove the hardness causing salts from water. Here, we are speaking with respect to feed water in a boilers. That means type of water used in industries. It must be pure from hardness. Otherwise, some problems will be rises. That is known as boiler troubles. So, for example, scales, sludges, and etc. And caustic embrittlement, very important boiler trouble will be we have to face. So, we must be remove hardness causing ions from water before taken into the boilers as a feed water. That's why we have to apply some techniques to remove hardness from water. Some of few techniques are geolite process, ion exchange process, lime soda process, and reverse osmosis. Geolite process, ion exchange process, lime soda process, and reverse osmosis. Reverse osmosis. So, by using these technologies, we can remove hardness causing ions from water. Okay, so let us say ion exchange method. Here, this method is also known as deionization or demineralization. So, what we can understand by seeing the title of this technique, ion exchange. That means here ions means hardness producing ions. So we know that which type of ions causes hardness to the water. For example, calcium sulfate, magnesium sulfate, calcium carbonate, magnesium carbonate, like that. So here we are going to remove this type of ions like Ca plus CO3 minus, Mg plus SO4 minus. So we know that if the ion carries positive charge, that is a cation, and ion carries negative charge, that is the anion. So these type of ions exchanged by using this technology, that is known as ion exchange. That means exchange of hardness producing ions from water by other species. And this process also known as deionization. Here D stands for remove ionization, ions, removal of ions from water. And this is also known as demineralization process. D means remove minerals. So we know that calcium, magnesium, these are called as minerals. Why? Because when we are speaking with respect to human being, drinking water must contain some amount of calcium and magnesium. Why? Because here calcium and magnesium are act as a minerals for our body buildup, human beings body buildup. That's why here what we are doing, removing ions. As a part of ions, here we are going to remove calcium and magnesium. These are known as minerals. So here removal of minerals from water. That's why this technology is also known as demineralization of water. So, in this method, to remove ions from hard water, we have to use some resins, some resin which contains cationic and anionic. So, before going to the procedure, so what is a resin? It is a macromolecule cross-linked structure, cross-linked structure with microporous, microporous. So that is the resin. So here we are going to use two types of resins to remove ions from water in ion exchange method. That is anionic exchange resin and cationic exchange resin. Here, what is anionic exchange resin and what is cationic exchange resin? Resin which contains acid functional groups. Resin which contains acid functional groups. That is called it is cationic exchange resin. Cationic exchange resin. That means resin, R stands for resin, which contains acid functional groups. So we know that H plus is we are considered as acid. So this is a cationic exchange resin. Whereas resin which contains anionic functional group, that is ROH. That is ROH. ROH. So we know that here OH is the basic function. So R stands for resin, which contains basic function group OH. That is the anionic exchange resin. Okay. So resin contains acid functional group, that is known as cationic exchange resin. Resin contain basic functional group, that is known as anionic resin. Now these cationic exchange resins is able to replace whatever cations present in the structure with cations that causes hardness to the water. That means, so with the help of cationic exchange resin, we can exchange the whatever cations present in the water. That cations must be causes hardness to the water. So what are the cations present in the hard water? That is calcium plus magnesium plus. So by using cationic exchange resins in a ion exchange method, we can able to exchange these ions, that is cation, that is calcium and magnesium, which causes hardness to the water. Likewise, by using anionic exchange resin, that is ROH, this type of resins is able to exchange whatever anions causes hardness to the water. So we know that which type of ions and what anions causes hardness to the water. That is Cl minus, SO4 minus and etc. So these type of anions we can remove by using ROH. Here ROH act as a anionic exchange resin. Okay. Next, coming to the so these are the about that cationic exchange resins and anionic exchange resins. So cationic exchange resin contains acid function group, as I told you, and acid function groups, that is COH, SO3H, etc. These are capable to exchange their H plus ions from the hard water. For example, sulfonated quartz. Next, anionic exchange resin. Anionic exchange resin. So here these resin contain functional groups like, as I told you, basic functional groups, that is ROH, RNS2, etc. etc. Okay, so look at here. First one in diagram, you can see that is a cationic exchange resin, and next diagram indicates anionic exchange resin. So if you observe that in cationic exchange resin, that resin contain acidic functional group, that is sulfonated sodium, whereas in anionic exchange resin, some basic functional group is there, that is OH minus, that is OH minus function. These are the basic function groups. That's why we can say that this is the anionic exchange resin and this one is the cationic exchange resin. So as I told you, resin is the macromolecule which contains microporous structure and cross linkages. So this is known as cross linkage. This is a cross linkage in between the molecules of the complex. Okay, so this type of resins we are going to use in ion exchange method to remove hardness from the water. Okay, next coming to the operators. This is a ion exchange method or demineralization process operators. So let us see the operators. Here operators consist of 4 vertical tanks. These are represented as A, B, C and D. For our convenience, we are going to represent it as A, B, C, D. These are the 4 vertical tanks. These 4 vertical tanks are interlinked to each other, interconnected to each other. If you observe that, every tank must be interconnected. Every tank must be interconnected. Out of these 4 tanks, tank A contains dilute HCl and tank B contains cationic exchanger, that means cationic resin at middle of its position, and tank C contains anionic exchange resin, and tank D contains dilute NaOH solutions. Okay, so coming to the procedure, that means removal of hardness. Procedure in the sense converting hard water into salt water by using ion exchange method. So look at here, through inlet which is provided at top of the tank B, through that inlet we are passing hard water. So here we have to remember hard water in the sense water which contains both cations and anions of chlorides, sulfates, carbonates, nitrates of calcium and magnesium. So we are going to remove both cations and anions of the hardness producing salts. Okay, so first we have to process hard water through inlet which is provided at top of the cationic exchange tank B. So let us see what will happen when we are passing hard water. So when hard water is percolates through the cationic exchanger, which is present at middle of the tank. While water percolates through cationic exchanger, we know that cationic exchanger has acid functional group and it is able to exchange whatever cations present in the hard water. So we know that what type of cations present in the hard water? Calcium and magnesium. So while water percolates through cationic exchange resin, these cations are replaced by cationic exchanger. cationic exchanger. Let us see how it will be replaced. Look at here. Okay, so this is the cationic exchange resin. We are passing hot water through. So this cationic exchange resin can replaces the whatever cations present in the hot water. Similarly, MgSO4. Hot water contains MgSO4. That hot water is passes through the cationic exchange resin. It resin can able to exchange cation present in the hot water. Similarly, suppose if you take NaCl in the water. So what is the cations and anions in NaCl? Na plus Cl minus. So these cationic exchange resin exchanges cations present in the water. Next step, in going to next step, same water after removing cations, that water is passes through tank C, where anionic exchanger present at middle of the tank C. So here, which type of water we are going to passes through anionic exchange reagents? Water contains only anions. Why? Because already we removed cations by passing cationic exchange reagents. So now water contains only anions. So here, when water percolates through anionic exchanger, whatever anions present in hot water will be removed by anionic exchange reagents. Look at see how it will be exchanged. Look at here. So here ROH. This is the anionic exchange reagent. When passing water through the anionic exchange reagent, whatever anions present in the water will be replaced. So we know that which type of anions present in the water? Cl minus, SO4, etc. So look at here, HCl. So resin can replace HCl with OH minus. Look at here. So this process carried out for some time. Okay, passes of water through cationic exchange reagents, removal of cations present in water by using cationic exchanger, and after removing cations of the hot water, that water is passes into the tank C, where anionic exchange reagent is present at middle of the tank. While water percolates through anionic exchange reagent, whatever anions present in the water will be removed by the anionic exchange reagent. This process is continuous for a long time. Afterwards, there is no chance to further purification of hot water. Why? Because after some time, cationic exchange resin contains only cations of hot water. Similarly, anionic exchange resin contains only anions of hot water. That's why these two exchanges are exhausted. How it will be exhausted? It will be regenerated by HCl and NaOH respectively. So first we have to regenerate cationic exchanger. That's why we had to process dilute HCl from tank A to tank B. So let us see what will happen when we are passing dilute HCl into the tank B. So this is a cationic exchange reagent. We are passing HCl into the tank B, which contains cationic exchange reagent. So here cationic exchange reagent is exhausted. That's why it has to be regenerated for further purification. So in this condition, so there is no chance of further purification. That's why we had to regenerate it. So how we can regenerate it? By passing HCl into the tank B, which contains only cations of resin. So let us see what will happen. When you are passing HCl into the tank B, which contains only cations of hot water, that cations of hot water is replaced by acidic functional group. Okay, then our cation exchange resin has been regenerated. Now this resin is again taken into the tank B and passes hot water and continue the whatever procedure for removing of hot water. We can continue. Similarly, this step is known as regeneration of cationic exchange resin. Similarly, we had to regenerate a basic resin also. Let us see how it will be regenerated. Basic resin. So this is a anionic resin which contains only anions of hardness producing salt. So it is exhausted, it has to be regenerated. How it will be regenerated? By passing NaOH from tank B. So what happens when we are passing NaOH into the tank C, which contains only anions of hot water? Then basic resin will be regenerated, that is anionic resin will be regenerated. Now we can continue the further purification. We can continue for further removing of hardness producing salt from water. So that is about ion exchange method. So that is a procedure for ion exchange method. Next, coming to the advantages. What are the main advantages of ion exchange method? By using ion exchange method, we can remove both cations and anions of hardness producing salts. It produces water very low hardness. It is very good for treating for using high pressure boilers. This process can be used to soften highly acidic and alkaline wastes also we can remove by using ion exchange method. Next, coming to the disadvantages. So what are the main disadvantages of ion exchange method? So this method is too much of expensive. Why? Because here we are using resins. The cost of resins are very expensive, and turbidity must be removed below 10 pm. Whatever water we are going to remove hardness by using ion exchange method. So that is about disadvantages of the ion exchange method. Next technique, that is lime soda process. This is also another technique. By using lime soda process also we can remove hardness from the water. So here calcium hydroxide and soda as we are going to use as a reactants. Calcium hydroxide CaOH, that is known as lime, and soda S, that is a soda, Na2CO3, Na2CO3, that is a calcium carbonate. Sodium carbonate is used as a soda. So by this process, soluble magnesium and calcium salts are removed as a precipitates. Let us see the procedure for lime soda process. So before water treatment, calculate amount of temporary and permanent water hardness, then estimate the amount of lime and soda and add to control with carefully. In case of temporary water hardness, the following reactions takes place. So look at here. So what is a temporary hardness causing salt? That is a calcium bicarbonate and magnesium bicarbonate. These type of salts causes temporary type of hardness. So what happens when you are adding calcium hydroxide to the temporary water? Calcium bicarbonate is converted into calcium carbonate. It is an insoluble PPT. This PPT can be removed by through a filtration process. Similarly, magnesium bicarbonate. This is a type of salt causes temporary type of hardness. So what happens when you are adding calcium hydroxide to the water which contains magnesium bicarbonate? That magnesium bicarbonate converted as a in case of permanent type of hardness. So we know that which type of salt causes permanent type of hardness to the water. That is calcium sulfate, magnesium sulfate and magnesium carbonate. So what happens when you are adding Na2CO3, that is a soda, to the hardness producing salts? So look at here. Calcium sulfate is converted as calcium carbonate and magnesium sulfate is converted as magnesium carbonate and magnesium carbonate is converted as magnesium hydroxide. So these three compounds are insoluble precipitates. These are found as insoluble precipitates. These are removed through filtration process. Next. So lime soda process is two types. That is cold lime soda process and hot lime soda process. So in cold lime soda process, reaction takes place at normal temperature. In this process, we are going to use this type of tank. Here, this is the hot water. Chemicals we have to use it through an inlet and it is a stirrer. So in this method, we are going to pass hot water through a continuous stirring. Stirring is nothing but mixing. So look at see what happened. Afterwards, this water is allowed to settle now. Next, coming to the hot lime soda process. In this process takes place in presence of hot conditions, high temperatures. They are about boiling point of water. So that is 100 degree centigrade of temperature. So as a result, precipitation become almost complete very quick. This process is more effective than cold lime soda process because of temperature. Chemical mixing process same as cold lime soda process, but steam is applied in Mitchell tank. Okay, na? So that is a hot lime soda process. So hot lime soda process water softener systems are exclusively used for boiler purpose. So in this process, it is possible to remove magnesium water hardness completely and calcium hardness may remains very low. Here, these are corrosive gases also we can remove by this hot lime soda process. This is a diagram for hot lime soda process. It is look like a cold lime soda process, but only difference is here we have to introduce some steam into the Mitchell tank. Heated steam we have to induce. So that is about hot lime soda process. Next, advantages. So advantages of the cold lime soda process. It can be carried out by 4 ways. So as per necessary, it is required type can be used. Lime soda processor, there are 4 types of techniques are available. Soft water obtained by this process has residual hardness about 50 to 60 ppm. By using lime soda process, we can remove hardness up to 50 to 60 parts per million. Disadvantages. Disadvantages of cold Ramshara process. That is, it is a slow process because reactions during water softening takes place in very dilute solutions at room temperatures. So it does not give residue less than 5 to 60 ppm until 550 to 60 ppm of remove hardness we can remove by using Ramshara process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.